Hi, my name is Alex, and in this video I'll show you how to power on a LED. What is actually a LED? A LED stands for light emitting diode. So it's a diode, but what is a diode? A diode allows the current to flow to one direction. What is special to these LEDs? The thing is, when the current flows through this LED, we have light. This is the difference. Also, the LEDs comes in various colors like red, yellow or green. Let's begin with making a simple calculation and find out what the current is, maybe do some simulation and also go to the bench and make the circuit. I made the simple circuit to turn on a LED. So I hook up this LED to a power supply with 5 volts, but the problem is why I used this 220 ohms resistor here. Well, so I need to limit this current so that LED doesn't burn. How to hook up this LED to this power source in the proper orientation? So this is the plus and minus, or anode and cathode. So how I could possibly remember this orientation? I will choose to remember this side as minus. Now we will need to find out the current. The current, I will assume, is in this way, and I will note with I. So how I could calculate the current that flows through this LED? By using the Ohm's laws. I have V, where V is voltage, equals the current multiplied by resistance. So this is the formula. So if you search on Google, you will find out that on LED it's like 2 volts or 3, depends on the color. So I assume that I will have a voltage drop about 2 volts. That means here I have 5 volts and here I should have 2 volts and here 0 volts. Here we have 5 volts. Then we have a resistor with 220 ohms. So we have a voltage drop. But this voltage drop needs to be sufficient to turn on this LED. And then we need to go to 0 volts. So we have 5 volts minus voltage drop on this resistor minus voltage drop on this LED, and finally we will get 0 volts. 5 minus 2 equals, where 5 minus 2 is the difference between these nodes, and that means is the voltage here, equals I, where I is the current, multiplied by R, where the R is 220 ohms. So here we'll have 3 equals current multiplied by 220, and then I equals 3 under 220 ohms. Then let's calculate this with a scientific calculator. So the current is 0.0136 amperes or 13.6 milliamperes. Also, this calculation need to be made with these values already transformed. For example, here we have 5 volts and here we have 2 volts, so this need to be volts. If we have millivolts, we need to transform that millivolts to volts. Also here, if we have kilo ohms, we should transform that in ohms. So yeah, you can actually make this calculation with kilo ohms or millivolts, but I will prefer to make some transformation before, so I could get a correct value. Let's go to the simulation and try to make this circuit. use Proteus Design Suite, and simple by that, I'll press New Project, and now we have a window where it asks us to give a name. I'll give LED turn on, and also a location to save this project. I'll choose Browse, I'll save it to the desktop, and I'll press Select Folder. And I'll leave like this, New Project, click Next. I'll set this to default, click Next, 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 and Finish. By scrolling with the wheel on the mouse, we can scale this in and out. To pan this, click on the scroll button and you can pan in every direction you want. To do so, we need to be sure that we are in component mode and press the P from this left side. And let's say I will need a resistor by typing resistor in the keywords text box. And by pressing model primitives, we have the preview of the schematic. By just clicking on this, we add the resistor component in this list. So now let's search an LED, and I want a green LED. By typing LED in this keywords text box, I have a plenty of these LEDs, but I only want that LED that I could see the animation. So let's see a green LED here, purple, orange, green. That is active animated LED model green. We have the schematic model here. We'll double press here and then we pressed OK. To place the component, we just need to select one of these and just click here. And in this state, the component is not actually placed, but we can decide where to place, and I'll put here. Actually, the direction is very good, but if I want to rotate this, just click it and press plus, and you'll see that orientation changed. So now I want a resistor. I'll select this resistor. I'll put here the resistor, and as far as I can see is 10 kilo ohms, and I don't want 10 kilo ohms. So to change it, I'll double click and I will say 220 R. R stands for ohms, or I could just simply say 220. Press OK. Then I need a power supply. To add the power supply to this, we should find here the generator mode, DC, because I want a DC, and here double click it, put a name. I will put VCC and put a voltage here, like 5 volts. Press OK. Now we need the ground, because this simulation needs a ground to simulate this entire thing. To put a ground, we need to go to terminals mode, ground, just click it, and in this state the ground is in another color, so we can decide where to put it. And I will put here. Under this, I will move the component by just click on it and drag the mouse. Also, I will want to move this, and to make the connection you need to place the mouse here at this terminal, and you can see a red square. Press it, go where you want with this wire. I want to go here. We'll see another square that confirms the connection is made, but not entirely. We need to place it here and press it. And also let's do this here and here. So this is the circuit. To power on this, to simulate this, we should press run the simulation and the LED is turned on. So I want also to see what is the current that flows through this LED. We just need to press stop, cut this wire, and here put an ammeter DC. So we'll go to virtual instruments mode, DC ammeter, place it, and as far as I can see it's kind too big, and make some connection. Just click on it and change the display range to milliamps. Press OK. So let's start on this thing. The simulation was successful. On this calculation I got 13.6 milliamperes, but on this simulation I got only 12.6 milliamperes. Why? The problem is this is not accurate, but at some point it matters, but for now only matters to turn on this LED. So now let's hook up some DC voltmeter to see the voltages on this circuit. I want to press stop to stop the simulation, and then by selecting DC voltmeter I will put a voltmeter here and here. By clicking on it and press the plus, I will rotate this because it's kind ugly, or you could simply just put it here and make the connection like this. To copy the component in Proteus, you just click on the ground and from the block copy press it, and now I can place these grounds here, then press play. So here we have 5 volts and here we have 2.24 volts. Now let's go on the bench and make the actual circuit. A 9-volt battery, a cable, so I could connect this battery to this power supply and I will get 5 volts from here. And I have a breadboard, so I could just put these LEDs in here. Why I choose many LEDs? To see the different colors. And also I have 220 ohms. Let's start to make the circuit. First, make sure that here we have plus, minus, and also here we have plus and minus, so I need to orient this in the current position. So let's put this in proper way. Be careful so not damage the pins. And in this moment here I have 5 volts on this rail, and here on this blue rail I have the ground. So let's take this resistor and put it like this by connecting 5 volts here, and then take a LED, a green one. And if you want to know which side is plus and which one is minus, you could guess by looking at this long lead. But what if you don't know because the lead was broken and you don't know actually where is the plus and minus? If you can see here, if I can make sure the camera could see, you could see here that the biggest material is the minus. Or you could use this toy here by turning on, put the LED here, be careful to be different number here, just press on this to make sure this will not escape from here, to make, and also to make a good connection. Select M tester, press OK, press OK, testing, and as far as I can see, 1 is for plus and 2 is for minus, and I will make sure I will put this in the proper way. like this. We have 5 volts coming through here and 5 volts here through this LED, and I need to hook up this rail to some ground. And at this moment I have some cables to make this circuit so beautiful. And now, well done. This is the first circuit that you will make. Now let's power on this thing. Let's connect this battery here. Then let's connect this connector and turn on. The LED is turned on. Great, this is a simple circuit. So now I can change the color of this LED because I was bored and I want a red LED. Now I have a red LED. I want a yellow one. And I have a yellow one. Now I want to see what is the current that flows through this LED. So let's see. I will put this back. I just drag this a little bit. I'll put here. As you can see, I will take this post and put it here. And another post here. And now I have 5 volts coming from here through this resistor, through this post, but there is no connection, so I can't turn this LED on. But if I connect this multimeter in series, and let's see how I could place it so you can see, I will just move this to the milliamperes, set it on setting to 20 milliamperes, and then take these probes and connect these probes in proper way. 30 milliamperes. Great. So it worked. So this is today's videos, and if you want more content, please subscribe to my channel and press the like button and give me some suggestions, because this is kind of my first channel based on the engineer stuff. Thanks for watching and goodbye.